Okay, so we're talking about Sefu. First of all, is of course stands for solve the equation for the unknown. What it means is if you have an equation such as average velocity is displacement over time, if you're solving for average velocity, if that's what the question is asking for, you're fine. You can use the equation as it's written. But if the question says, how far did the bird fly, and they're asking for displacement, this is your unknown, displacement. It is mixed on that side of the equal sign with delta t, which they told you is 12 seconds or something. And before you do this problem, before you solve this problem, you always have to get the unknown on one side of the equal sign and all the knowns on the other side. So, unknown on one side of the equal sign, and all the knowns on the other. That's what Sefu is. Okay, how do you do it? How do you actually solve the equation for the unknown? I've got a couple of strategies here that will help you with 98% of the equations we're going to use this year. And those are equations that have different quantities that are multiplied and divided by each other, such as the equation we're using right now, velocity, average velocity is displacement over time. Okay, strategies for Sefu. Strategies. I suggest that no matter what you're solving for, the first thing you should do is get everything, all the variables, all the quantities on one line. In other words, no fractions. Okay, so in this average velocity equation, there's a fraction on the right-hand side. And so the first thing I'm going to do, no matter what I'm solving for, is I'm going to get rid of that fraction. To do that, I have to get the delta t out of the denominator. How do I do that? I multiply both sides by delta t over 1 times delta t over 1. That has the time delta t cancel from the right-hand side. And I end up with, on the left-hand side, delta t times average velocity is equal to delta x. Okay, if the problem is asking me to solve for delta x, if they're saying what's the displacement, I'm done. I've got delta x is equal to average velocity times time. You might often write it with the unknown on the left, average velocity times time, if you prefer. But we're done with that. If, on the other hand, we are looking for delta t, the second step then would be, now you have everything on one line, divide both sides by the knowns, which are with the unknown, spelled E, with the unknown. So, in other words, in this case, if I'm looking for delta t, if that's my unknown, and I know average velocity and I know displacement, then I say, oh, well, I've got an unknown. I want to leave that by itself. I'm going to divide both sides by the knowns which are attached to the unknown. In this case, that's average velocity. So I'm going to divide both sides by average velocity. That leads to the average velocity canceling out on the right-hand side, and I get delta x displacement over average velocity equals delta t. And now I've solved the equation for delta t. So, for this equation, the three versions I have are delta t is displacement over average velocity, displacement is average velocity times time, and of course the original form, which is average velocity is displacement over time. Okay, I hope that helps.